Hey guys, welcome back. So today we are working on this 4000 psi hot water pressure washer. It is powered by a Honda GX390 and separately has a diesel tank for the oil burner, which is actually powered by electricity. Anyway, this one comes to us from a friend. He's had this for many years. He says it's a low hours machine, and he went to start it up this spring. It started up just fine on choke. As soon as he flipped that choke off, he heard something pop, and the engine abruptly stopped. And the engine hasn't rotated since. So there's really only one of two possibilities here. Either the engine is locked up, or I would say more likely the water pump locked up. There is a lot of oil all over the pump and under the pump as well. So there is a sight glass here. It's actually kind of hard to tell. It is hazed up a bit, but I am really not seeing any evidence that there is any oil in that pump. So I was hoping to do a rebuild video actually on this pump, but I think a lot of rebuild kits kind of focus on the high pressure water side of things. And if this actually ran out of oil, it might be less expensive to just buy a new pump. But I'm getting way ahead of myself. We don't even know what is locked up. It could, for all we know, be the engine. So let me get set up a little bit better and get going on this. All right, so first things first, let's check the engine oil. Yeah, plenty of oil. It is very dark though and needs to be changed, but it is at least full. And let's check the pump oil. That's not a good sign, but there is oil. But I would say it's water contaminated. But yeah, definitely oil. So the pump did not run out. And actually, it doesn't look as bad as I first thought. Whatever was on the dipstick was a little bit misleading initially. Yeah, but the oil that's in the pump doesn't look too bad. Well, so far, things are looking pretty good. At least we have oil in the engine as well as the pump. So 2 more quick checks we can do would be to actually pull the starter recoil. That way we can try to rotate the engine backwards. And we can also pull the plug, make sure that the engine's not hydrolocked. Potentially fuel or water got into that cylinder, preventing the engine from rotating. And no, I can't rotate the engine at all in either direction. I can't really see in there, so I'm going to just blow it out. Just in case there's any junk. We don't want it falling into the engine. All right, the plug is out. It is nice and dry. We've got a BPR 6ES, which is the correct plug. The engine, though, no change. Still locked up. So I think the next move here is probably just to separate the pump from the engine and see which one is locked up. So we've got movement of the crankshaft now that the bolts are removed. So let's just check the other side, make sure we see the starter cup, the fan and the flywheel moving. Okay, good. So the Honda engine seems to be fine. It's rotating now that the pump is loose. So the issue is with the pump. So let's get all the lines going into the pump disconnected. We'll get the pump off the crankshaft, and then we'll open it up. Potentially it's an easy fix. So we've got the water inlet right here. This is the high pressure out. This line here is just to hook up to like detergent. And then we have one final connection here that goes down over to the oil burner. So I'm guessing that might trigger the oil burner to shut off, when the pump isn't flowing water, but I'm not too sure about that. And this actually looks like a quick disconnect. So this kind of looks like a quick disconnect. I might be wrong about that. Yeah, it is. Although I don't think it's been used in a while. There we go. Okay, we're free. Let's see if we can get the pump off the crankshaft. We'll try to gently persuade it. There could be something locking it onto the crankshaft, although I would kind of doubt it. But it is on there. I actually think I see a set pin. And if the pump won't rotate, I'm not sure how we're going to rotate the crankshaft to align it into the little window that I see on either side here. That could be a problem. You can just see it right there. Not quite enough that I can get an Allen wrench on there. And I'm not sure if that's the only set screw. But with that where it is, the pump's not going to come off the crankshaft. So either we need to free up the pump or we need to cut out a bigger window, I'd say right here. So that's probably what I'm going to do. I don't think it's going to hurt the pump. Most likely the pump isn't going to go back on, but even if it did, I still don't think it's going to be a problem to have a hole right there. So let's drill that out, and then we can at least access that set screw right there. Actually, before I go drilling things out, let's pull these caps and take a look at the valves. There's 3 caps here, 3 caps there. This way we can at least pull the valves out, get a look at the plungers. Maybe that's what's jamming things up. Ideally we'd get this thing rotating again before we resort to drilling out some material. All right, so that's a fail. I can't get on there too well because the bolt's kind of in the way. So maybe we should try the other side. I'm going to put a couple bolts back in, or at least one bolt, and we'll try to get access to these valves. No, can't get that off. So that has me wondering why. I would not think these caps would be on there ridiculously tight. Oh, all right, that one's coming. Doesn't feel good though. Feels like I'm tightening it. Is this righty loosey? Or do I just have the wrong wrench? Yeah, so 1 inch does not fit. 1 1/8. A little sloppy. So, yeah, this might be metric. Yeah, so it looks like this is 26.8. So let's call that 27 millimeter. In inches, it's just over an inch. So my inch socket would not fit. My 1 1/8 fits, but it's not biting in well enough. It's going to round off these if I keep trying to loosen these up. These are pretty tight. So I think I need to make a trip to the store and buy the right size socket. So it is late at night. I can't get a 27 millimeter socket right now, but I'm not really sure I need to. I thought we would start with the valves. It seemed easy enough at the time, but given I can't get these caps off right now, I don't think we really need to. If we remove these 8 bolts right here, we should be able to lift this head right off the pump, valves and all, and potentially that will free things up and allow the pump to rotate so that we can get that set screw out of there. Yeah, that is on there pretty tight. Ooh, that one may have broke loose. It did. All right, that one wasn't too bad. It's coming off slowly, but I don't think it's supposed to be this tight. All right, I'm going to try to rotate the engine, see if these pistons move. And no, the pump is still locked up. So I might try a little bit more force. Maybe try rotating the engine backwards and see if we can get any movement out of this. I just realized I missed a pretty important clip here. I came around to the machine like we discussed and used a long screwdriver and was able to break the pump free. It was pretty tight at first, but after a couple revolutions, things felt pretty normal, and I was able to align that set screw. So let's continue on the other side and get that set screw removed and try to remove that pump. Okay, good. The set screw was not tight at all. Or it was snug, but not locked in place. So was that the only set screw? Not sure. The pump still won't come off, so let's rotate the engine, see if there's any others. Nope, that is the only one. Yeah, I think the issue with the pump is water. Having the pump up on its side, I do see water coming out of the oil fill. So likely there's just rust on the crankshaft. That's what bound this pump up. All right, let's see if we can't persuade this off. And the answer would be no. It is on there still. So that is not good. Don't think we have any other set screws. So right now I'd say the only thing holding this on is likely some rust. So I'm going to try to use the brass drift to just tap this with a lot of force. Given that I see water dripping out of the crankcase, I don't think we're going to rebuild this. Just a rebuild kit for the high pressure side, it's probably like $80. And if we're going to go into the actual crankcase, that's, I'm just guessing, but I'd say it's going to be at least another 100. And at that point, probably should just buy a new pump. So I'm not having much luck getting the pump off, but what I am noticing is that we do have a threaded hole right here and also on the opposite side. So we can use that to kind of press this off the crankshaft. I guess the only downside is that, if it's really stuck, all we're going to do is either break this casting or potentially put a hole in the crankcase cover. That said, though, there is kind of a thicker part of the case that we can align this to give us the best chance possible. So I have a couple of M8 bolts. Those seem to thread in. We don't have a lot of threads here, but it should be enough to at least get it to start to move. And once it breaks free, hopefully we can just pry it the rest of the way off. Something happened. Yeah, it's definitely moving out, but we're out of threads on this bolt. So we're going to have to swap these over to something a little bit better. Don't like those sounds. Okay, we're out of threads again. I'm going to try the pry bar. Maybe it'll get it off this time. And that would be a no. So let's take these out, find some longer bolts. Out of threads again. Well, that took a lot longer than I thought it was going to. You know, once we got the pump to rotate, I thought we were home free. We got the set screw out, and yet the pump wouldn't come out. So after about a 2-hour struggle, we finally got the pump off. And now that it's off, I can see why it was so hard to get off. There is a lot of rust on the crankshaft, and that was rust jacking that pump in place. And there was what looked like a seal at one point on the crankshaft, and I got to imagine the purpose of that seal was to keep the water out from doing what it did, but clearly that seal has seen better days. Anyway, all during that time, you know, the pump was dripping, and you can see it right here. There is milk chocolatey looking oil, and that is the color of oil when there is water mixed in it. And there's also a bunch of water drops that all came from the crankcase of that water pump. So it's not looking too good for that pump. So let's pull the drain bolt. We'll drain out the oil and see just how bad it is. All right, so we can drain the oil here on the back side, but now that we have the pump finally off, we can just pull the fill and drain it that way. And actually, I'm just noticing too, there is a crack right there in the center piston. And actually on the other side, we have cracks pretty much the whole length on these two. Actually, 3. So something happened. I think this pump got really hot to cause that damage. Because even when we got the head off, the pump still wouldn't spin. So there's damage not only, I guess in the top end, but also in the bottom end. Yeah, doesn't look too good. Yeah, there's a lot of water, a lot of mud, a lot of chunks. That's pretty bad. And I wonder too if this actually hydrolocked. I couldn't see the oil level, but maybe that's because it was above the sight glass. Because clearly water got in there. And that likely overfilled the crankcase. And just an up close look at what came out. So a lot of it was that milk chocolate oil, but you can see what first came out was water. This actually hasn't mixed yet with the oil. So yeah, definitely not a good thing for a crankcase. So I have not had one of these pumps apart before, and likely I'm going to do it the wrong way. But there's already a lot of damage, and this is probably a good one to learn on, rather than one that is more easily repairable. So I think if we pull the nuts off here, that the pistons, or the plungers, theoretically should come out, although that one is not. Let's try the next one. Yeah, it is loose on the shaft. Although I guess that's a relative term because I can't move it by hand. But it is spinning. Okay, well, it almost looks threaded, although I wouldn't have thought that it should be. And the piston, well, this one shattered right in half. and the other half is hanging on. So let's try its neighbor. Okay, and they're not threaded. That one pulled right off. Yeah, I don't know if those are supposed to be that hard to get off. Probably not. Okay, there's one, an O-ring underneath to prevent water from getting in the crankcase. And there's a closer look at the pistons. So none of them in very good shape. All of them damaged, although I guess this one's probably the best. We only have one small crack right there, but the others definitely suffered a lot of damage. Now, as far as getting the rest of this open, I think probably the next move here is to remove these bolts right there. That will allow the bell housing to come off. And then we have a few more bolts we can also pull. 4 right here on this window. And I think we have a few more here on the back side. So we'll get those removed, see where that gets us. And I also did finally find a data tag right here. It was under a bunch of oil, but it looks like the model number of this pump. TX151 QA. Pretty sure made by General Pump. Anyway, let's take this apart. You know what? Let's get this one in the vise. All right, well, maybe I was wrong. These 4 bolts, they're no longer holding something on. I assumed it was the bell housing, but it's not coming off. So we'll try a few more hits. Otherwise, yeah, we'll just move on. Yeah, it's starting to move. Okay, let's keep going. Okay, we're in. And I called this a crankshaft earlier, but it actually looks a lot more like a cam. You know, we have lobes and what appears to be, I wouldn't say they're connecting rods, but, you know, the lobes do actuate these up and down. So it looks like the last part of this is right under here, under the sight glass. So we'll get that removed and free up whatever's in there. And then I think we can probably slide this out. All right, so not exactly what I was thinking I was going to see. This is just a sight glass, probably with a rubber seal behind there and a ball bearing. So this piece, theoretically, should just be able to pull it out. So let's give that a try. I think the odds of this coming out are actually pretty slim because the ball bearing looks pretty rough, and actually I can't even turn it by hand, although I guess it could be bottoming out here on the vise. So let's raise this up a little. What's facing down are what essentially are the kind of the connecting rods, but still, yeah, it's actually bound up again. So definitely, I would say a bad ball bearing on that side. Or maybe something else. So let's try to get that sight glass out, and maybe we can drive this camshaft out from the other side. All right, and there's actually a snap ring holding this in place. So it's a good thing we got that sight glass out of the way, because this cam would not have come out with this in place. Although that snap ring seems kind of rusted in the groove a bit. Yeah, it's definitely rusted. That side's lifting out. Only about a quarter of it is. And the other side is locked in there. Yeah, that is not budging. Let me tap that a bit with a screwdriver. Well, we got that side free, but it's not free on the other side. So I think this is just going to break, which is fine. We can take it out in pieces. All right, we got more of it freed up. Not all of it, but I'd say about 60, maybe 70%. So the camshaft, not in great shape. You know, there is a lot of pitting all over the camshaft as well as the journals. So yeah, not a good thing, although I don't think that's why the engine locked up. We do have a roller bearing, actually right here, and this bell housing was very hard to get off. So, you know, I'm thinking either this bearing was locked up, or maybe the one over here on this side of the pump also spins. It actually doesn't feel terrible, though. It is a little crunchy, which is to be expected given the water. And that's what it looks like inside the crankcase. So these right here, I'm going to say, can probably be pulled out. You know, we just have this piece on the bottom, which, yeah, I was going to say it must be a washer. It was just kind of stuck. But they will come out. There we go. So just pinned in place. Let's take a look at the others. Journals definitely have a measurable amount of wear. And that one is probably the worst of the three. So yeah, there's not a whole lot of good parts here. You know, the crankcase is good. You know, if you actually wanted to rebuild the pump, you'd have to replace pretty much everything, at least on the crankcase side of things. So let's keep going. Let's take apart the water side. I'm not going to say it. So I made a trip to the store, picked up a 27mm socket, and it occurred to me after the fact that this could actually be 1 1/16 inch as well. You know, either way though, this is a much better fit, so hopefully we can break this free. Yep, that one came free. That one is going to need a bit more work. Oh, and that one actually is loose. So maybe I got that one earlier. Let's try this one again. Okay. These are all spinning now. So we've got 3 of these. They're all the same. And these are essentially check valves. You know, they let water flow one way, but not the other. And let's get this fitting off while we have it right in front of us, actually both of these. And then we'll rotate this and get the other valves out. Wow. I think I need a longer wrench. Well, making a little progress, but we're also losing these soft jaws in the process. So I'm actually going to get this off first. We're not actually going to reuse that, but I am curious about it. That is the thermal protection for the pump. So if the pump overheats, you know, that is supposed to open up and let water out. And my friend did say it was leaking, squirting water out for some time. You know, it wasn't something that just happened. So either it's related to the failure, the pump was just overheating every time he used it, which, looking at that oil, I'd say is a good possibility. Or the valve just failed, which also is pretty common. Yeah, and I can blow right through that. So whatever mechanism is in there, I would say it doesn't work anymore. Although, to be honest, I don't see anything in there. You know, I was expecting maybe a bimetallic strip. I'm not sure. Anyway, we'll set that aside. And really the last thing here I can get off, I think, of the valves on the other side. The unloader, it is part of the casting, although I guess we can take that apart as well. See how that works. Actually, I'm going to get rid of those. These are on there extra tight. I have to use a cheater on the breaker bar. Otherwise, these aren't coming out. For the unloader, there is a spring in here, so we're going to have to be aware of that. And we might actually have to remove that nut first. Although I don't think we need to. This is actually... Yeah, I take that back. We probably do need to remove this at some point. The spring in there, it tightens up or decreases spring pressure. And this cap is actually turning this piece right here to change that tension. And I'm guessing if we remove this piece here, we should see that spring. And not much to see, I don't think, in here. We are left with this piece here. So this unscrews from that. And right there, that is the valve. And it's being held in the closed position by the spring. So yeah, let's see if we can break that apart. Okay, and there's the spring. This here is just a set screw. Looks like it sets the max. You can turn this in, so the max spring pressure. So, on this pressure washer, you'd want it to stop at 4,000 psi. But theoretically, you could back off that and drive this in a little more to get some more spring tension out of it. Looks like a double spring. And that's it. That's the valve right down there. So the spring holds this closed, and only water pressure can overcome that spring pressure. And it just opens a bit, but that is enough to let the pressure out from the high side of the pump, which is the top row, and it just circulates back to the low pressure side of things. So this pump, it's really pretty simple in design. You have 3 pistons, and they're all actuating or timed differently, but they're all doing the same thing. You know, they're taking the water coming in from the tap right here, which is just normal pressure. It enters this area, kind of surrounding and filling it, and then you have these check valves down here. So what happens is the piston pushes the water. The water has nowhere to go. There's a check valve down on each of these, so the water can come in, but it can't go back out the same way. And then when the piston pushes down, the only place the water can go is up above, because you have another check valve, and it's oriented in such a way that it will allow the water to go up. So this becomes the high pressure rail, and then this is the output to the pressure washer. And the system right here, when you go in bypass, it just opens up the valve. So what happens is the high pressure recirculates back down to the low pressure, and it just does that really indefinitely until one of 2 things happen. Either the pump overheats and locks up, which will happen quickly, or the little valve that I took out on the side will open up, and that bleeds off the hot water and allows some cool water to come in from the tap to keep this cool. So, you know, a lot of people don't realize this, but these pumps, they are cooled by the water entering them. As soon as you let go of the trigger, that water just circulates internally, and the heat builds and builds. And after a couple minutes, you're doing some permanent damage. So what I do and what I recommend is that, you know, start the pressure washer with the handle depressed. You know, it starts a lot easier, not to mention you're doing what's good for the pump, and just don't let go. Unless there's some sort of emergency situation, keep the water flowing through the pump. And when you're done, just shut the engine off, then let go of the trigger. So the pump side of things actually is in pretty good shape. You know, it really just needs a seal kit for about $87. You could get this part up and running again. The issue is the crankcase side of things. You know, I've been trying to price out the parts that we need, and for the most part have come up empty, which is likely a sign that nobody does rebuild the crankcase side of things. But I did find the OEM pistons, and they sell for $107 each, and we need 3 of them. So the pistons alone plus the seal kit, we're already up to $400, and I'm sure once you factor in these other things, I'd say we're at $700, maybe $800, which doesn't make sense. You can get a new good quality pump for about half that. So that is what I'm gonna do. Of course, before I place that order, you know, I think we need to at least get the engine started and make sure there's no surprises. So I'm not gonna go too crazy cleaning this up. We haven't heard the engine running, and of course, it's not gonna build any pressure. And the good thing about a pressure washer too is that it can clean itself when we get to that point. So I'll just clean it a little bit right now. We'll get the recoil back on. And I'm also going to put a new plug in. You know, this engine, I would say, has not seen a tune-up since new. So after it runs, we'll change the oil as well. So we're going to put a brand new BPR 6ES in place of the other. I already checked the gap. We're right on at 30 thousandths. So what do you suppose the odds are that this is just going to run well and not need a carb clean? You know, it is a Honda, so I'd say the odds are good, but I think it has been some time. I actually spoke to my friend again about this machine, and although he said it did blow up early in the year, I kind of get the impression that this happened a couple years ago. The ignition was left on, the fuel was left on, and the choke in the on position, and the tank, I did take a look. It is not empty. Thankfully, there is no rust, but the color of the fuel is not good. You know, it has definitely been in there a few years. So I'm thinking before we try starting this, let's just get the old fuel out of the tank as well as the carburetor. You know, put some fresh fuel in there and then give it a try. So yeah, I like the fuel in the tank. It is pretty dark, but there's no water. And I'm hoping that the carb looks as good as the tank does. So maybe we should remove the bolt and just drop the bowl, see what we're dealing with. Yeah, not too bad, actually. There is a little bit of debris on the bottom of the bowl, but overall not too bad. So I'm going to clean that out with some carb cleaner, put the bowl back on, and we'll try out the carb. And since we're here, let's take a look in the sediment bowl. And I'm thinking we should actually fill the tank right now and just kind of flush the fuel line out, since we know there's old fuel in there. Sediment bowl, not too bad. Really no corrosion, just a bit of debris. So I'm going to wash that out as well. And then we'll bleed the system out and get this back together. All right, so I've got some fresh fuel in the tank. And it looks like it's already coming out clean, so that is good. I noticed too, the tank has damage around the top of the tank, so I don't think the cap is actually going to make a seal with the damage like it is. So, you know, likely we are going to have to replace or fix that tank. I'm not sure how well that shows up on camera, but the tank right there, it is bent up quite a bit. And the cap, it's not going to make a good seal. Even if I bend that back, you know, I think this tank is going to have issues. But let's test it and find out if the tank's any good and if the carb's any good. The carb is actually running this engine quite well. No issues at idle or high speed. If it wasn't for the fact that we're actually forming a puddle of fuel under the carburetor, I would say we are good to go. Unfortunately, the carb does have a slow leak, so I think we need to pull that carb off and clean it properly. I'm surprised at how dirty this carb is. Actually, the whole machine's pretty dirty. For a pressure washer, usually they operate in a pretty clean environment, but I know my friend uses this to clean some heavy equipment, so I'm guessing a lot of this is probably just splatter off of the machines he's cleaning. So the fuel valve, it is part of the carb. So when you pull this line, you need to be prepared to plug the line or drain the tank. All right, let's have a better look at this carb. We know it's not terrible, and it was running the engine pretty well, so, likely there was just a little bit of debris caught in the seat. Needle looks good. And it's a plastic seat. Nothing obvious. And this machine does idle, so we're going to have to set that idle set screw back where it was. And it was about 2 turns out. We can fine tune that later if need be. And the pilot jet's under here. And there's also an adjustable needle there, but there is some tamper protection, so we can't actually pull that out. But I do like to turn it just to break up, potentially any debris that's caught in there. And we also have the main jet, so let's see if that'll come out. Yep. That's it. So the emulsion tube, a little bit dark, but doesn't look terrible. And the main jet, we know it's not clogged. I can see light through that. So yeah, the carb's in pretty good shape. I'd say the biggest issue was the outside. So I'm going to spray this with carb cleaner. The fuel valve, I think I'm going to leave alone. It can come apart, but I don't think we need to in this case. That did seem to be working. So yeah, let's get some of this heavy stuff off. We'll give it a good soak and put this back together. All right, so the carb is done, cleaned up pretty well, at least on the outside. The inside wasn't that bad, but I am willing to bet that it's not going to flood over anymore. So let's get this back together. And before bolting it on the machine, I'm going to bench test it. I'm going to fill it with fuel and just make sure that the needle is forming a good seal. Okay, let's try it out. So I'm going to get the carb back on the studs just to hold it nice and level. And we'll top it off with fuel. And then just let it sit. See if the needle holds. All right, we're slowing down. And we're just about stopped. So I'm going to fill it up right about to there. Yeah, it looks like that's the best we're going to get. There is an air bubble right here. But I think that's good enough. So let's give this about 10, maybe 20 minutes, and then we'll check back. So while we wait for that carb test to be done, we need to clean up the crank. This is the camshaft from the water pump that we just pulled off. And it doesn't go on any easier, really, than it came off. So we do need to clean this up. So I'm just going to wet sand it with a little bit of WD-40. And it shouldn't take much. But we want to get this nice and smooth so that the new pump goes on without issue. Yeah, incredible. 20 seconds of sanding. It's like there was never anything wrong. And you can see the inside here is pretty rusty. It's leaving a lot of that rust behind. But that is a pretty big difference. So when we reassemble this, I'm going to use a bit of grease. Or maybe some anti-seize just to help the next guy. I think we're good. It's been about 10 minutes. The bowl is nice and dry. Fuel level is holding steady. So I'm going to get the carb reinstalled, and then we'll do another quick test and just make sure that the engine continues to run well. Well, I think we're good, as far as the carb goes. So, I do want to get that oil changed while the engine's hot, and I'm also going to place an order for a new pump. Now, there are a lot of pumps that'll fit on this machine, and I don't know a lot about pumps. Mostly I work on generators. So, I did reach out to another YouTuber who goes by the name of Rusty Rooster. He does a lot of pump rebuilds as well as pressure washer videos. So I asked him for a few suggestions, and based on his feedback, I picked out a pump. I think it was about $340. So that will be here in about a week. All right, we get the engine filled back up right to the top. So, not much to do other than wait for that pump. Well, it's a few days later, and we've got ourselves a new pump. So hopefully I got the right one. Assuming I did, the install should be pretty quick and easy. I also picked up a brand new tank. So the tank that's on there, it is damaged, and the cap is not making a seal. So, I think technically we could fix this, with the right size socket. We could probably pound that back into shape. But until the tank is dry and free of fumes, not something I want to do just in case I make a spark. Anyway, as far as the damage here, I did share with my friend that I thought the pump overheated. He told me there was water coming out for actually a couple years out of the thermal protection valve. So I asked him if he ever ran the pump dry or let the water circulate for too long, and he said no on both counts. So I explained to him that the pump needs cold water to stay cool. And it dawned on him when I said that what happened. So he has a shop separate from his house, and that shop has a hot water heater. So when he doesn't want to fire this thing up, he just connects a hose to the hot water heater to wash his equipment. Well, that hot water heater, it's also tied into his tap outside of his shop. So when he does use this, he's actually putting hot water from the hot water tank through the pump. And that water is at least 120 degrees Fahrenheit, and the thermal valve kicks in at 145 degrees. So this pump had no way to cool. And that explains what happened here. So now that he knows that, hopefully there's no repeat with the new pump. All right, so the pump did come with new hardware to secure it to the engine, but we do need to reuse the old key. So we'll get just a bit of anti-seize on here, a thin coating, and then get the pump installed. All right, well, the pump was easy enough to install, but now that it is, I can see we have our first problem here. So the old pump, the high pressure came out right here. And we do have a plug, but this is actually, I think, an alternate path for the unloader. I don't think we're going to get high pressure out of there. So we do need to connect in right there. The line that we have running to the tank, it's not long enough. And even if it was, it would have to swing way outside of the machine here to connect in. I guess another option is that we could put it on this side of the pump, but to do that, we would need a 90-degree fitting, which I don't have, and that would also cause issues with this pressure switch. So I'm thinking, let's keep the pressure switch where it belongs. As far as this problem goes, if we get a 90-degree right here, then this will be facing the right way, and we can connect this up to the tank. So while we wait for that fitting to arrive, there's still a few things we can do. I think we should get the switch plumbed in. We'll get the new tank installed, and also pull this plug. This is only here for shipping. Instead, we should put the dipstick in place, which also has the vent. This came out too easy compared to the old pump. Had the breaker bar for it, but it was not needed. All right, problem number 2. This is supposed to be pipe thread. At least it was on the other machine, so this should have gotten tight. And instead, I can turn it all the way in. We're definitely off to a bad start here. All right, so the pump bolted on to the engine without issue, so I thought we were home free. Really, all we needed to do was plumb it in and connect the pressure switch. And that's when I realized we kind of have a problem here. So the pump appears to be British standard pipe, parallel thread, and I verified that with the parts diagram. The confusing thing is that the unloader, according to the parts diagram, is NPT, and they included some NPT fittings to connect to it. And it's also connected together with what appears to be an NPT fitting, according to the parts diagram that the manufacturer provides. So this theoretically should not be compatible, although you can go from tapered to parallel, but it needs to be the same standard. So then things got a little bit worse when I pulled this plug. I saw that this was a parallel thread, and the seal is done with this O-ring right here. And when I took the fitting for the pressure switch and threaded it in, I realized this is also a parallel thread. So a parallel thread into a parallel thread needs an O-ring. The threads don't seal and they never tighten up. So I did move the O-ring over, but that O-ring just squeezed out. The shoulder here on this fitting, it's not large enough to accommodate an O-ring. So I was wondering, how did this seal on the old pump? And the answer is these threads are tapered in the pump. And although this was sealing, technically this is not allowed. You can screw a tapered fitting into a parallel fitting like they did here, as long as it's the same standard, but you're not supposed to screw in a male parallel fitting into a tapered fitting. even if they're the same standard. So that on the original pump doesn't seem right, although it did work. And the confusing thing here is that, I'm not sure what this fitting is. Is this NPT going into British standard pipe? And what am I going to do about this? So I did reach out to Rusty Rooster. I asked him what type of thread he uses on these pumps, and he said NPT. He actually reached out to the manufacturer, and they said the same thing. Just use NPT on the British standard pipe, and you'll be fine. So, yeah, I'm not sure I like that answer. I am going to do a little bit more research on it, but there are differences. The NPT, although it is 3/8 like British standard pipe for what we're working with here, there are differences in the thread. The NPT, the threads are sharper, and they're actually angled differently. I think they're at 60 degrees. The other thing is that NPT has 18 threads per inch, whereas British standard pipe has 19 threads per inch. The threads are at a different angle, and they're actually rounded. So, yeah, this is kind of a hodgepodge here, and I'm not sure how I want to address this. So I need to do a little more research, give it a little more thought. Of course, the easy thing would be to do what everyone else does, and it would probably be the most cost-effective thing as well. But yeah, I'm not sure how I'm going to proceed on this. Either way, though, I do need to remove the unloader from the pump. This has to be turned 90 degrees in order to connect it to the tank. And I want to do that now, at least get these fittings out so I can see for sure what this is. So I'm going to get this hose removed completely. And besides removing the unloader, I'm actually going to have to remove the inlet here on the bottom, which seems wrong on a new pump to be taking it apart like this. I think it's unavoidable. The unloader isn't going to unscrew, with this in the way. There we go. It also makes me wonder why this line is so long. So when this goes back together, likely I'm going to cut that down. Sometimes they do run external tanks so that when this unloads, it actually sends the water to like a 500-gallon tank and just circulates that water through the pump rather than just circulating the water internally, which will heat up pretty quick. So I guess maybe the longer line could help because you're actually increasing the capacity of the water a little bit, so it'll take slightly longer for that pump to heat up. Gotta remove that fitting too. All right, and this is the coupler that just came out of the pump. Double checked the parts diagram again, and it confirmed this is NPT. But a quick check we can do is the threads per inch. So this is 18 threads per inch, which is NPT, and it fits in there perfectly. So that was the pump side, which should have been the British standard, not NPT. And yeah, same thing on the regulator side. So this is actually an NPT coupler. So unfortunately, it is confirmed. The manufacturer said this was 3/8 NPT into a British standard pipe parallel thread. You know, is it right? No. Does it work? Apparently good enough, at least with the right sealant, because that's what the manufacturer does, and that's what it seems like everyone does, at least in this country. So I'm going to have to give this one a little bit more thought before placing an order. You know, I also double checked this fitting as well. This one's a lot harder because this is 1/2 inch, I believe, NPT, just based on how sharp the threads look. But the threads per inch, they are actually the same on NPT and British standard pipe, which is 14 threads per inch. So although these are still different standards, they are a lot closer. And you can see this threads in actually quite a bit further before it gets tight. So yeah, that's also a little concerning, but it does get tight. So yeah, I'm going to think about this a little bit. I don't like doing things the wrong way, but in this case, it might be cost prohibitive, at least in this country, to do it the right way. So while I think about this, you know, let's get the new tank installed. And I also want to try out the burner. You know, you should have water in it, but you can run it for a few seconds without water just to test the functionality of it. So I really don't want any more surprises or any more setbacks. So yeah, let's finish up the tank. We'll test out the burner, just make sure everything is good there, and then I'll order some parts and finish this up. All right, the tank is free. Now, accessing the fuel line might be a problem, in which case we'll have to remove the airbox again. But let's see if we can lift this up enough to get the fuel line off. And yeah, the fuel line's actually right up front here, so that should come right out. Gonna leave these a little bit loose. We'll get all 4 on and then come back and snug them down. So the tank is done, and we are full of fuel. So when we get the pump issue sorted out, we should be ready to go. So next, I do want to test the burner, but I'm not going to do that in here. Under the best of conditions, I think we are going to see some flame coming out the top. So we need to make sure this is out of the way. And if there's a critter nest in here, we could see quite a bit more flame. So unfortunately, I can't really see down there to see if there's anything there. So the safe thing would be to put this outside. And to do that, I'm going to use the forklift. I did that in the beginning. I never really explained it. But this cart, it really wants to flip over on the tank side. And initially, I tried rolling it up the ramp and almost lost this whole thing on the side. So I turned it around, tried to push it up the ramp, and it almost fell over the other way. So the tank makes this very unstable. And really the only way to safely do this is to lift it off and set it down. All right, let's give this a try. I've got the oil burner plugged in. The main switch is off. Now, when I turn that on, I would not expect anything to happen. We do have the pressure switch still connected. Obviously, there's no pressure in the system. So let's turn on the switch, see what happens. Okay. And there is a fan running. Kind of sounds like the oil burner is running, but it's not actually lit. So it might just be the ignition and maybe the fuel pump that's turned off when that pressure switch doesn't sense any pressure. So let's get something to activate that switch, see if the flame comes on. And so I'm just going to use the plunger. Usually that's pushed on this side by the water. Oh yeah. There it is. So it's just the ignition. All right. So no issues with the burner. Well, it's been about a week, and I think I have all the fittings needed to finish this pump up. The two here on the top, the 90-degree fittings, those are just standard National Pipe Thread or NPT. The two brass ones, these are the ones that really should have come on the pump from the manufacturer. Although they both look like the same type of tapered thread on each side, they are different, and it's actually labeled as such. So the one here on the top, that is British Standard Pipe tapered thread, and on the other side this is National Pipe Thread, NPT tapered variety. So these will get installed right on the pump, and then from there on out it'll just be National Pipe Thread. So make sure we get the right side here. Now, this does require some sealant. You can use Teflon. In this case, I'm using True Blue. Or you could use both. But you want to make sure whatever you do use that it's tightened properly. About 1.5 to no more than 3 turns. And just to clarify, it's 1.5 to 3 turns after finger tight, which is where we are right now. So I'm just going to mark it, make it a little bit easier to keep track of how many turns. And for now, I'm just going to do 1.5 turns because once we add the 90, we might need to tweak this a bit, to get things to work out properly. So let's tighten that down. Okay, we'll leave it there for now. So next we're going to get the quick disconnect secured. This is for the pressure switch. And this one I am still a little bit uncertain. According to the manufacturer, this is a 3/8 pipe thread, national pipe thread. And it should be tapered, but I don't see a taper on it. But it's what we've got. So I'm going to give it a try. If it leaks, then we might have to find another switch. So I think it's safe to add this knob back on for the unloader, as well as the bypass hose, although I guess we need the fitting for that first, so we'll get that on next. So this fitting, I know for a fact we can't go 1.5 turns. I tried it before putting the thread sealant on. And it bottomed out at about 3/4 of a turn. So this one's not going to be very tight. We're probably at a 1/4 turn past hand tight. But this is also the low pressure side, so likely it'll hold. Otherwise we can turn this another 1/2 turn and just face the fitting for the unloader going this way, and we can loop around back to the top here. But we'll try this first. That's how it was when I got it. And if it works, great. If not, we can revisit this. So I did end up giving this fitting that extra 1/2 turn. It just wasn't tight enough. So now we're pretty much bottomed out. The threads are fairly tight, and hopefully the sealant will do what it needs to do. But that just makes it a little bit more awkward to run this line. So before it was coiled up, and actually we could probably do the same, although I'm not sure we really need to. Do we need that extra loop? Kind of doubt it. So I might cut it short right about there and call that good. So we'll get this plunger reinstalled into this fitting. It was pretty gummy, so I did clean it up, and I think it's good to go. But before trying to fit it, I'm going to use a little bit of O-ring lubricant so we don't cause any damage. And let's see if it fits. And more importantly, does it move freely? Yeah, that feels pretty good. So there's a few pieces to this to do it right. We have this washer that goes on first, the spring, and then we actually have another washer and O-rings. So this should be interesting because we don't have a lot of extra room here at the tip. So we get that smaller washer and then this small O-ring right there. And assuming it all stays in place, we can now just get the switch connected. Like that. And then we'll slide that pin in. So we're getting close to firing this up. And I want to make sure we swap this cap out. This is essentially a plug for shipping. You don't actually want to run the pump with it because the oil dipstick, it's actually a vent. And you need that in place before firing this up for the first time. And like the other pump, there is actually a set screw in here. So we'll snug that up. And last but not least, we have the connection from the pump to the tank. And the existing hose, it is super close, but it doesn't actually reach the fitting. So I did pick up a brand new one. It's actually about 8 inches longer, so it might have the opposite problem, but too long, it's probably better than too short. So let's get this one off. I've already loosened it up, so we'll get that removed and get the new one installed in its place. So I wanted to break this one free before ordering the new line because I wasn't sure I could get a tool in there. Just the placement of the rail versus this fitting, it's not the best. think that's it. So far, so good at 60 psi. We are completely dry, at least on the pump side. What I didn't see coming, though, is over here on the hose reel. It is leaking pretty bad at 60 psi, and of course, it's only going to get worse at 4,000. So, yeah, I'm not sure I have any parts to fix this right now, but let me look around. Maybe we can bypass this for now and just try out the core of the machine. Yeah, it looks like the O-ring's pretty chewed up on this side as well as on the other side. So this can be rebuilt. You know, I do have new O-rings, but nothing rated for this pressure. So for now, we're just going to bypass the hose reel. Well, I think we just swapped one problem for another. So this quick connected is leaking and needs to be swapped out. Now, we do have some fittings down here that we could try, but I'm not going to torture you with that. I'm just going to shut the water off, swap out some fittings, and see if we can find a combination that'll work here. Well, I think we're back in business. I was able to use one of these fittings in place of this corroded one. And with an adapter, everything is now connected like it should be, and we are not leaking. So I'm going to take a second, clean up the mess I was not expecting to make. And I also need to bleed the air out of the system before getting this thing fired up. You know, right now we do have a tip on the wand. I'm also going to pull that off. The hot water tank, those coils have a lot of rust in it, and it's just going to clog up that tip. So, you know, to start with, that tip will not be there. We're just going to test out, you know, the function of the burner as well as the switch and the pump. And once we get the system up to temperature and we're sure everything's working right, then we'll add the tip back and actually put this thing to work. All right, we'll give this a quick try with the burner off. You know, I don't think there's going to be a whole lot of rust coming out, especially because the burner is not going to turn on until we install the tip. But let's just get it started, make sure that there's no funny noises, that everything looks good. If that's the case, we'll add the tip back and actually try to build some pressure as well as some heat. So we'll get the ignition on, fuel on, choke on. All right, choke off. All right, we're going to try it again. This time we have the tip, so we are going to build pressure. And the burner should turn on, but let's start it first with the burner off. We'll check for leaks, and if we're good, we'll turn that burner switch to on. All right, not too bad. The engine and the burner, they performed absolutely flawlessly. And of course, the star of the show, the pump. This pump did quite well. For the most part, leak-free. The only thing I noticed over here was the fitting, of course, between the pump and the pressure switch. I kind of suspected that was going to leak based on the type of thread that it is. They're not compatible, as far as I can tell. And the fact that it has a very slow leak tells me the same. So, I think the only fix for that is likely to swap out that switch. So I'm going to let my friend decide what to do on that. As far as the rest of the machine, for the most part, we're good to go. I think the biggest wrench in the works here was the hose reel. I was kind of hoping for the best. When working on the machine, I saw a bunch of rust here and figured it was probably going to leak, but I didn't think it was going to be that bad. So, he does need to replace that. But the core of the machine, it is back up and running and perfectly usable as it is, which is a lot better than how we started with this machine. So, at the end of the day, the thing that caused the problem was running hot water through the pump. So now that my friend knows not to do that, I'm expecting he's going to get a much longer life out of the new pump. So I hope this video helps someone. Thanks for watching.